Welcome to this IoT talk. We are glad to see the auditorium is almost full and everybody here on the last day of Devoxx. We are going to share a little bit about adding eyes, ears, and mouths to your IoT project. So I would like to ask you, who is already engaged with IoT in somehow? Okay, lots of people probably doing cool stuff. So welcome to this talk. Vinny and me, we are working with education since 2001. We have a training company, and we run a big event in Brazil. We are board of Sou Java, the Brazilian Java community. We also have a Dutch chapter there and run the Devoxx for Kids events. We just moved some years ago to IoT and start building some cool hardware as well. So now we are in the frontier of software and hardware for IoT. We had the pleasure to get the Duke Choice Award in 2011 with our first IoT project. It was an automated coffee machine, but we were paying lots of attention on the framework that evolved since that to now. Most important on our mini biography is that we have a son and a daughter, Maria and Rafael. Very important attribution. I must say thank you to this great program, College Java Champions. I'm not sure if you all know about this, but this is a program that helps people to spread Java knowledge around the world. So it's a program kept by Oracle, but it's independent. It's driven by the Java champions by themselves, by ourselves, and with that we got support to travel and go to conferences and help to spread the knowledge around the world. So thank you for the Java Champions program. Just to share a little bit about our background, we did some cool projects with IoT. So we worked with horse telemetry, just for racing horses to know when they were jumping or what were their accelerometer and GPS and lots of sensors for people that were interested in buying those racing horses. We have also worked with smart boats, so Vinny is passionate about sailing and all our family is. So we put lots of sensors and a broken automatic pilot, so lots of playing with the boat. It's a giant robot, but very cool to play with. We also tried creating a smart helmet for a Brazilian startup. So on this helmet, we used Raspberry Pi and a camera and GPS and lots of things just to, the community is growing around bicycles, so the idea was to connect these people in a community and on a social network behind the helmet. We also did some cool projects with kids, so we helped a public school to implement low orbit satellites called TubeSat, and these were 5th grade kids that were having their first experience with creating their own hardware and doing programming on top of it. We also created a Minecraft robot, so it was a robot that has bidirectional communication. You can inside the game turn on or off the lights from the real world, and from the real world you can make changes inside the game. So when you enhance the humidity on the real world, it can rain inside the game. So lots of cool stuff for kids to play with Minecraft, but using adults' technology to do that bidirectional communication. We also create, of course, some home automation or smart building projects for local companies in Brazil to control infrared and all other appliances. So Vinny would like to do a little introduction to basic concepts for IoT.
Good morning, everybody. Thanks a lot for coming to our talk. The concept will be very fast, just to introduce you the architecture that is behind all this toy. So I need to show you which kind of software we are running in the edge devices, in our Arduinos, in our gateways. We have here also the Gemalto concept board that runs Java ME, and I will be explaining the architecture and the software and the hardware that we developed the last few years. So, oops. Okay, so we have 4 layers in IoT space. The first layers we call as edge device, which is the very low energy and limited computer in the border, grabbing data from the sensors, controlling relays, controlling transistors, controlling motors and things like that. So the edge device, most of the times we supposed to use microcontrollers instead of microprocessors. Is really low energy, so you can survive in batteries for months. You have all the sensors and controllers. May not support TCP/IP. You may have some edge device using like a Zigbee or Z-Wave, X-Wave. I don't remember the standard here. But infrared, you have many types of devices that they can't run TCP/IP because they have a very limited memory. But the edge device, most of the times you don't have operational system, which means that you are running your software in a bare metal way. So it's a direct communication between your software and the hardware. With that, you can have real and hard real-time operations, which means that it's not something that will perform great, but it's something that will not allow delays. That's the concept of real-time devices. And next to that, we have the gateways. The gateways, we are going to use microprocessors or system-on-chip that aggregates microprocessor, video, wireless technologies, and much more. They are low energy, not very low energy. They may support something then beyond TCP/IP. The edge device, we used to have just a few responsibilities for edge device. In the gateway, we can have many responsibilities like persistence, security, integration, and limited real-time support in the gateway because most of the times you are running Linux, and for real-time is not that good. So we have the cloud layer. So once we have the gateway connected to the internet, our idea is to send all the data that we capture in the edge device and make the intelligence. So once you start grabbing the data, you can start making the things smart. And you have social network and all the integration over the internet. And finally, we have the consumers. The consumers can be low-level consumers or machine-to-machine consumers using protocols. The most famous are MQTT and CoAP. When we have machine-to-humans, we used to use REST and web service. So we can have phones, tablets, and we can have devices, more sophisticated devices like cameras, like Kinect or Intel RealSense. That is the camera that I have here in my laptop, and I'm going to show you today. So the edge device, we have this guy running Zigbee. So it's something that I have this battery, and I can this device can rest for many, many days with this battery because Zigbee is very low energy consumption, and so I can have a very different topology of network with Zigbee because Zigbee work with mashup network. So one device can talk with another, that can talk with another, and so you can have a very long distance network based on Zigbee. So that's our edge device for today.
Just one quick question. Who already is familiar with Zigbee?
Great. Wow. So the gateway is the entrance point. We are really used to have our gateway in our houses for the television, and for our internet access, we have the router that connects you to the internet service provider. This is the most important part of the IoT for me. And Java performed great in the gateways. And the gateways, they are responsible for converting data and protocol. And we can have different types and sizes, like very small edge devices with microcontroller, Bluetooth low energy, Zigbee, Wi-Fi, or 3G, small system on chip, like Raspberry Pi, Udo board, Intel Galileo, Intel Edison. Medium, like the powerful single board computer. We have many single boards that are coming with IMX6, which is a very powerful system on chip. And Intel is doing a great job in this space. They just launched the Intel Edison that has 3 CPUs, 2 Quarks and 1 Atom CPU. And you can have big computers like plug computer, or even using your PC, your desktop, your notebook to be the gateway when you are in the development time. So here we have this device that I show you, the Zigbee. We also have here this wood surfboard. This guy is using our board together with Gemalto concept board. So I have in the back of this surfboard the Gemalto concept board running on 3G. So this is a great experience. This is a great module from Gemalto, and I really recommend you. We have many years working with EAGS 5 and EAGS 6, which is the main module from this board. And it runs Java ME, the old one, old but gold, the Java ME 3.2, but it just works. You have updates over the air, you can have security, and it's amazing technology. And we are going to show this today. And
on this case, the most important thing of using Java ME instead of Java SE is that you have APIs for accessing all the accelerometers, sensors, and everything. So that's on Java ME, and it's cool from this board. Lots of people have been using Gemalto around the world, so it makes your project independent. So because it has its own internet for that. So we have use cases on Amazon for monitoring trees, for instance.
The forest, not the cloud computing. Yeah, they are monitoring the trees, and they have accelerometer, they have the 2G connection, and if someone just cut the tree can notify someone is cutting trees in this space. So it's a way to take care about our forest. A very nice Internet of Things implementation. We also have here a gateway running with Raspberry Pi and Java 8, which is this wood laptop. As you can see, I love to work with wood and IoT. So we own a CNC machine in our house. So we replaced our dining room for a cutting machine. So,
so when they cut the tree, we get notified?
And we have here inside this laptop the Intel Edison, also running Java C, Java E. But Intel Edison already comes with Bluetooth low energy and Wi-Fi connection, which makes a great device. Intel Edison, like Raspberry Pi, is all about having the best technology to make IoT. Like you are using something that is 10 years old in terms of microprocessor, in terms of hardware architecture. When you talk about Intel Edison, is the future devices, future technology. So we did this guy, we call this guy as IO tablet. It has the Intel Edison, the Raspberry Pi, Wi-Fi, Bluetooth low energy, and we also have the Zigbee module here. So it's a very nice development gateway. So that's how it is inside. Our idea to build this tablet is to have a multi-board computer. Instead of have one computer with 4 CPUs running the same operational system, we did a kind of laptop that we can have different boards running different operational system, and just pressing one button, you can switch from one operational system in one board to another board. And another thing that is good for people that smoke is that we have a smoke lighter here. Oh, look at that. Apple never did a laptop like this.
And on this project, Raspberry Pi is responsible for rendering, right?
Yeah, Raspberry Pi provides all the user interface and the screen, the HDMI, because Intel Edison doesn't come with a video adapter. And we are using our startup project called IoT Surfboard. We just launched it in Brazil. It has many sensors. It is Arduino based, and we can have connections using Zigbee, Wi-Fi, Bluetooth. We have temperature, humidity, alcohol sensor, real-time clock, relay, and infrared. So it's a very nice board for prototyping and start playing with IoT. We are launching this board next year in the Kickstarter US. In Brazil, we did a crowdfunding, and it was very successful. So it seems that we are in the right time. And all the demos will be based in this board, but all the demos you can do in your house, replacing our board for Arduinos plus a proto board. So you can have something simple, but very useful to try our APIs and try our software.
And just one quick thing here. Lots of people ask us sometimes, should I use Arduino or should I use Raspberry Pi? Should I use Arduino or should I use Intel Edison? And as Vinny explained it, they have different purposes, right? One is the edge device who controls the sensors and the actuators and all that. And the other board is a more stronger board that has an operational system, has lots of abilities, has Linux, and you can do that, use that as the brain of your project and integrates to the internet and filters data and work with data before sending to the internet. So IoT Surfboard, the IoT Surfboard doesn't replace Intel Edison or Raspberry Pi, but it's designed to work together with any of those richer boards.
So our menu today, in terms of devices, we have the IoT Surfboard number 1, which is this one. This one is plugged using the USB cable, which is a serial connection, directed to my laptop. So I have my laptop working as IoT gateway, running all the Java services. The next one is the Zigbee device, this one, and this one is talking with the IO tablet, and this guy is the gateway. And
so these two, they are talking through Zigbee, right?
Yes, they are talking through Zigbee.
So they are not on Wi-Fi. They are using this different protocol. For people that are not familiar with Zigbee, it's different protocol that made the communication possible, but it's not Wi-Fi.
And we have the last one, that is the surfboard, using the IoT surfboard plus 3G connection, and the gateway is the concept board. So we have different types of gateway. We have a regular laptop, we have a Raspberry Pi and Intel Edison single board computer, and we have the Gemalto concept board, which is a very small gateway. So we have different sizes and types of gateways here.
So the gateways are all in Java?
Yeah.
But the two first are running with Java SE, and Gemalto is running with Java ME.
Yeah. In the edge device, we are using Arduino-based board. So we are using in Surfboard the Arduino Nano, which is the small Arduino that you can buy. It's a very production Arduino, go-to production Arduino. And we have an API that we developed the last 5 years for our called IoT Surfing API for Arduino. And here we have the IoT Surfing protocol, which is JSON-based. And in our gateways, we have the IoT Surfing Service, which is a Java microservices kernel. very good, that supports everything. The IoT Surfing Services is the guy that will integrate the audio system, text-to-speech, video recognition, and so it's the manager of all the IoT ecosystem that we have here. Let's look at the edge device code. So we have some Arduino code here, and we are saying that we have a red LED plugged into the port number 10, which can make pulses, so I can control how much red, the intensity of the red light, the green, the blue. I have a relay, I have a speaker, I have the alcohol sensor, relay and speaker, they are digital, just 0 and 1 to turn on and turn off. And the alcohol sensor is analog, so I have the value between 0 and 1023. And so we have more complex sensors here, like temperature and humidity sensor. They are not like just reading a digital port or just reading an analog port. Here we are sending the function that will make all the complex process to read this sensor. And the boards that we are working, they have multiple behavior. So I can choose the behavior by pressing one button. I can change the behavior of the board. Like I can make my edge device, if I want to pulse very fast just one sensor, or I can left my edge device as a kind of serial listener, so it will be waiting for requests about the sensors and controlling the things. So it's very easy code. Arduino is easy in the beginning, but once you start putting many different types of sensors, you can have problems in terms of timers concurrence, in terms of multiplexing, like the analog ports in Arduino, they are multiplexed, and we try to solve it, to solve all these kind of problems that we are having the last 7 years in this nice piece of software.
And just want to add something here. This multimode framework, he told, for people who are familiar with Arduino, we wanted to create a playground, right? A place where you can play with the sensors and all that. But as all kids, we want to change the toy we are playing, right? We don't want to play with the same toy for the entire day. So when you are programming to Arduino, each time you do a program, like I just did a breathalyzer, then I'm playing with the breathalyzer. But then you want to play with the relay. So you need to connect your Arduino board to your PC and upload the new sketch. And this is very annoying. So this idea of modes that Vini showed, it's just to you to be able to upload up to 10 different sketches to Arduino, and then when you press the button, you change the mode. So you are able to play a little bit with the breathalyzer, then change the mode without uploading and change the sketch again and change it to a relay control or a tweeter machine or any other thing you want. So that's the beauty of this.
Yeah. And we used to show the Arduino, but we have a version of this framework for x86 boards, and we have also a more low-level framework based on HTML AVR Studio. So we take it out the Arduino so we can have more control over the resources that is very limited. Like in our case here, we have the RAM. The free RAM that we have here is around 2008 bytes of free RAM, so that's very few RAM. So we have the JSON protocol. Based on the sensors you have in your board, we are going to work with JSON protocol to read the sensors. So you will see that this code will affect all the other layers of our architecture. So after I have this guy plugged in our gateway, I would be able to send a REST or MQTT message saying red 25050, and so red will be on. And so this JSON protocol make it very simple to start reading the data from MQTT or REST and build your own web interface, because JSON is very easy to deal in HTML and jQuery. So that's the relation between what you are declaring in your device. And so with that, we have discoverable devices. So I can plug the cable, and the gateway can ask, oh, who you are and what do you have? So we have this framework to make it more easy to manage in the real production. And from the edge and the gateway, so here we have the edge, the gateway, and the JSON messages coming through the MQTT and REST protocol. And with that, we can have any kind of MQTT client or subscriber. We can have any type of REST client, Android, JavaScript, Node-RED. Node-RED is one client that I'm really enjoying. So to start playing with our devices in our first demo, we are going to use a client for MQTT called MQTT FX. That's from our friend James, and thanks to James for doing such great job with JavaFX. And this is the best MQTT client, in my opinion. It's free to download, and is is Eclipse Pahu, using Eclipse Pahu APIs to work with MQTT. So let's go to the demo before showing the gateway. I'm going to connect to my MQTT broker. As you can see here, we are using the iot.eclipse.org, which is a public and open MQTT broker. Anyone can go there. Actually, if you know the name of my queues, you could be able now to control all my devices. It's not a good idea. Please don't do it. At least now.
But just for people that are not familiar with MQTT, if you are familiar with JMS, it is the same, right? But for IoT. So it's publish subscriber. We just publish things on a certain queue, and if you are interested, you subscribe to that queue and get information.
So I'm going to connect to the broker, and I have my queue here. And what I'm going to say is surfboard 0. Red 255 and publish, and for sure it doesn't work. Okay, let's try another one. Surfboard 1. Okay, here we go. This is working. So very fast. If you keep in mind that we are going to the cloud and back in here, so publish very fast. Let me check here, just 1 minute, sorry. Waiting command, okay. So let's do another demo, like I'm going to say surfboard 3G, relay 1, so now what we expected is to turn on the light, so it takes more time because we are going to the cloud over the 3G connection, so we have some delay. So
and again, this surfboard is on 3G because it's using Gemalto surfboard, which is behind and has the SIM card inside.
Let's try to turn it off. Publish. So here we go. We can see the delay. Okay. And since we have different devices, let's play with like this guy, red 255. And let's try to turn it on. Publish. Red here. Red. This guy don't want to work for some reason. Okay, red here and red here. Perfect. And now let's turn it off. So we can see that this guy is very fast, and there it takes more time to turn off the red light. It's not my fault. And let's do some noise here. Speaker one. Oh, now all the three devices are working. And now you can listen to the latency. Look at that.
The 3G
the 3G was the last one. So thanks Leica Mobile, it's performing great, at least until now. The Leica Mobile is the SIM card we just buy for nothing, like 10 euros, and amazing. So that's MQTT FX, and I'm controlling my stuff here using MQTT in a very easy way. Now let's look at the subscribe. Let's subscribe some data from surfboard 1, which is this one. So in the surfboard 1, each 5 seconds I have a new sample coming. So here we go. I have the JSON data. And now you already understand our talk. Now we are going to just make interfaces between toys, MQTT, and our gateway that can talk with our edge devices. So it's very simple. It's just 7 years of work and looking, but it's very simple now. So we are subscribing and receiving the data, all the data here. For like a surfboard 3G, we are receiving each sample each 30 seconds to avoid spending a lot of 3G connection. So it's amazing that when you start doing IoT projects, you start thinking about green energy, green data, and green process, because in the future we are going to have so many devices that you are going to buy a refrigerator that says, oh, this is green energy, green data, and green process. It means that the datagrams that the refrigerator sends to the internet is not heavy. If everybody start doing Internet of Things using REST, the internet will be very, very busy. So sometimes JSON can be heavy for Internet of Things. So you need to calculate, especially if you are running on 2G or 3G. So you can see here all the data from our Gemalto surfboard. Okay, thanks God for the first demo. We have the IoT Surfing Service. This guy is the Java service. Is our code and our hardware they are all open source. So if you want to use, to replicate, and to help us to develop, please, you are welcome. And the IoT Surfing Service, we provide many types of service like scheduling, timers, camera, audio, video, sensors, MQTT, REST, FTP. So it's a collection of very small services and integrated services that makes a lot of sense for most of the IoT projects we have in the market. So here is a piece of code. So all the services, they can extend different classes depending on which type of protocol you want to answer. In this case, I'm showing a service that is called My Service. We have here, we can have some REST method here, and we are overriding the process message. In the process message is the message that will arrive through the MQTT. And for each class, service class you write, you must do a config file. It's a plain text config file. And so here I'm saying that it's enable. I don't have any kind of timer process, so the interval is zero, mean that I don't want to have something running each 10 seconds. And it will be listening to the MQTT queue, global code /things /audio. So in my NetBeans, you can see here that we have many, IoT Surfing Service. We can have many different types of service, administration, audio, camera, I2C, JSON, MQTT. So it's a very large collection of classes that we have been developed in the last years. So let's do a live demo to show how does it work. I'm going to say now, I'm going to publish here. I will need the audio now. And I'm going to say audio. And I'm going to call a service that is called my service. Sample my service. I'm going to call this service. What I'm going to do here is just receiving the message with the name of some sensor, and I'm going to the kernel. I'm going to say, give me all the devices and search inside all the devices for a component called like alcohol or called light. And so if it can find, it will say the value of the sensor for us. So let's see if it's working. So what I'm going to say is to read the humidity. Okay. No. I'm doing something wrong here, humidity. Okay, let's pass this demo, no problem. I will show this demo using the Google Voice. So for doing the eyes, we are going to use today the Intel RealSense, which is a very nice camera, modern camera that's supposed to replace your frontal camera in a few years with gestures, voice, and face recognition. For ears and listening and voice recognition, we are using Android, so the Google Voice, and we are using the Tasker, and Tasker is a very nice application for Android automation, and we are using Auto Voice. And for the nose, we are using sensors like the alcohol sensor, and to the mouth, we are using the eSpeak, which is this guy. eSpeak is an open source software that runs on Windows, Mac, and Linux, support different languages, and we are executing using shell commands. We don't have any kind of Java API for that. And what I'm going to do now to show this guy, I'm going to stop my IoT Surfing Service, and I'm going to start again. I will need the audio again. Oops.
Welcome to Surfing IoT Services.
Yeah, it seems that you are pairing with Stephen Hawking, but it's a great service. And now what I'm going to do, we have our service running, and what I'm going to do is to plug my surfboard again, and you can see the process of board discovery running in background. So it will find, try to find the port. So connection established. Start interrogating.
Surfboard 1 plugged into Surfing IoT.
So it could say the surfboard 1 plugged. So it's very nice because very useful to this guy, because if you have a Raspberry Pi, probably you have the problem that I used to have, that is you get into a network and you don't know your IP address and you don't have any screen to plug in your Raspberry Pi. So I did a customization in my initialization process, in my Linux initialization process. Once the Raspberry Pi starts, it says the IP address to me. So it's a very simple and useful thing to do with this guy. So now it starts sending each 5 seconds the data. So actually the Java is saying to the Arduino sensors, and Arduino is answering the JSON content, and we are publishing the message in the MQTT. For voice recognition, we are using this guy, Tasker Total Automation. Someone have already used a Tasker? Okay, we can make a user group. Tasker is very nice. You can like do anything. If this, then that. If the CPU is this percentage and I'm running, I receive a message, then do that. So you can combine any kind of thing. We just used the Auto Voice plugin and MQTT plugin for Tasker. And let's try to, this is a very critical demo. So I'm going to open my Tasker here and ask to recognize my voice. Humidity.
Humidity value is 28.00.
So we can start talking with my computer. Let's try something different here. Noise. Let's see. Oops. Oh. Start noise. Stop noise. Thanks, God. So, cool stuff. The voice recognition I tried with Intel RealSense. We have the support in the camera, but it's not that good. For me, the only one that is really usable is the Google one. So I'm having very good experiences with that. I can do automation saying, move the servo to 10 degrees. And I can extract the number in the sentence, so you can do very complex applications with Tasker and the Google voice recognition. Congratulations to Google for such nice work. Sure that if you have a very good internet quality, like the internet here is amazing for a conference of this size, and you will have better results. The precision really depends on the quality of the internet connection. So Intel RealSense, you can sense hands, face, speech, and also the environment. Is like Kinect, but is much more for short distance recognition, like face expressions, and so you have multiple points to recognize your hand. Like you can make gestures like click, this. So you can make gestures like this. So it's very, very nice toy, especially because if you think that in 3 or 4 years, they want to replace your tablet camera for this camera. So this project is not just from Intel. The camera actually, who is building the camera is the creative, but it will be in the market very, very soon. It will be very popular. So if you are writing an email with a very angry expression, you can have some intelligence saying, oh, okay, keep this email, wait 30 minutes more. And so you can do this kind of intelligence, which can be very useful for people that have heavy fingers, I call it heavy fingers. So in the face, you can recognize movements and expressions. And you have the SDK. This is a very new product from Intel, and we are partners from Intel. They used to give us the hardware, all the hardware they produce in Brazil, they give us to test. And we have the SDK. The SDK is working with Java, but is much better nowadays with C#. But they still making good progress in the Java SDK. So you can do Unity, C#, processing, and Java interface with Intel RealSense. So let me show you the JavaFX integration with Intel RealSense. So I have here some samples from my friend called Felipe Pedroso. He's from Brazil. He works for Intel, and he's one of the guys that is very specialist in RealSense all around the world. So I'm going to execute this guy. And so now with my fingers I can move the cube like this and this. Like it? Very simple, but just to show the concept. So all the code is available if you Google RealSense demos application, and credits to Felipe. So what we are doing, we did an application that converts the gestures to MQTT. So what I can do is use gestures to control my stuff. And the gestures will send the commands, relay 1, speaker 1, red, and so you can make this kind of combination. This is the user interface. Sorry, it's still in .NET, but we are migrating to Java since the last SDK for Java is very good and very stable. And let's open this guy. And so I want to connect to this server. This is the queue. I want to target my surfboard 3G. No, I want to target all the surfboards. And if I make this, I want the speaker. If I make this, speaker off. So let's open the debug window, and let's start recognizing. Let's see.
The 3G.
The 3G was the 3G. Yeah. So, and this to exit. Okay, and now let's have more fun. Let's say that my first talk here in 2011, it was all about turning on and turning off a lamp using Java EE. I show many different ways to turn on and turn off a lamp. I'm still doing the same thing with different technologies. And so now let's try to turn on the lamp using the smile and turn off the lamp using the surprise expression. It's all about fun, but you can really have commercial applications for this kind of thing. We are just showing to inspire the people here. Let's turn it off again. Okay, good. Sometimes when we have many lights, the camera can be like more sensitive. Okay, so that's the eyes of your IoT project. And so to finish, we have the last, in our talk we said eyes, ears, and mouth, but we have the nose. And we have the alcohol sensor. And I was thinking that going to Belgium, the beer's land, and not drinking a beer during my talk would be a fail, you know? So I prepared a demonstration here where we are going to have the concept of reading the data from reading the MQTT sensors data from your website. So the PAHO API for MQTT for JavaScript is very, very easy and powerful. This is the code that you can use to start your connection. And once you connect, you can subscribe. So I'm subscribing the things surfboard 1. And so once the message arrived, you can just make all the JSON parsing and grab the data that you are looking for and analyze the data. So let's open my website. So I have my very, very regular website. I'm just going to refresh index/Devoxx. This is a special version of our website. And I'm going to drink a beer. Oh, in name of science. So, okay. Thanks, God. That's a nice beer. Hey. Oh, here we go. Someone is drinking alcohol at Devoxx. So that was our demos. I'm very happy that everything is working. Now what I'm going to do is to open this guy here.
And here, just to be clear, we could do bidirectional communication as well. So we could, make that board clickable, and then from the web you control the board, and from the board you control the website.
Okay, so we have some question here. This is from today? No? Today is 12? Or?
No, today is Friday 13.
13. No questions here. So, how many? This is from yesterday. Yes, I was here. So we are open to answer your question. Here we go.
What are the costs on the 3G network? Like, how does it always connect? It's always connected, or connects on demand? Or?
You can have many strategies for that, like having airplane mode, having a sleep mode, and once you stop accessing your 3G connection, it will put to sleep. And once you have some new signal coming, it will take a little bit more to start communicating. After that, it will be hot again. So you have many, many different types of configuration that you can do for that. Okay.
Põe lá na apresentação para a gente fechar.
So, our GitHub, I have my personal GitHub, where I do many things in an unorganized way sometimes, and the GitHub from Surfboard is being organized and publishing the new versions of our code. So you are welcome to clone our code and start playing with that. And so if we don't have more questions, I would like to say thanks for all the audience. See you around next year. Thank you.
But we still can handle questions if you want, if you have. Yes, here we are just showing several different connections, but in the helmet, we were using 3G tethering, for instance. So that's really nice to have as well.